So aspirants definitely need to prepare it. They need to prepare the application part. Along with that, they need to keep track on whatever is happening. Of course, we still have a long way to go because overall in India, a lot of money is not being spent on research in general. But having a dedicated mission for something is one set of an idea that we do recognize it, and in future we should be doing more in this area. So if you're trying to create some part, they can very well form a temporary structure on which cells can grow and help us engineer that part.
Hello and welcome to the conversational video series brought to you by VisionIAS. In today's session, we're going to discuss one of the path-breaking developments in the field of science and technology, which has shifted our attention from the megascopic or megascale observation and manipulation of properties of matter to the nanoscale, which is essentially nanotechnology. To enlighten us about nanotechnology, today we have with us an eminent faculty member of VisionIAS, Dr. Jasmine. Hello, ma'am.
Hello, Shiranjeet.
Ma'am, we hope you're going to share everything that you know to help us understand about nanotechnology, everything that is worth knowing. So let's begin this discussion with a simple definition. What exactly is nanotechnology?
I think the definition part you covered really well. When we talk about nanotechnology, we are talking about manipulation of material in the nanoscale, like you've mentioned. So nano is now 10 to the power minus 9. So this means we are talking about particle sizes in the range of 1 to 100 nanometers. And if you think of the size of an atom would be somewhere around 0.1 nanometer. So we are now talking about working around materials in the particle size, which is in the range of the atom size, so close to that, or the size of the molecules, if we can talk about that. So at that scale, at that level, what happens is the property of matter changes. For instance, if we talk about gold, we know gold is golden in color, right? That's the color of the metal. But if we bring that gold particle to the size of the nanoscale, that gold can be red, that gold particle can be purple. So that creates a variation, and that's how it is different from the traditional technology also, because at this level, at this nano level, the properties change. And taking advantage of these properties, we can have different applications. The biggest point why this would be happening is that there is a increased surface area. When the particle is smaller, its surface area is more. So the surface area to volume ratio, that increases. And that creates the possibility of creating materials, creating the same things which we have been using in a better way with different set of properties. Like the strength will be different, optical properties will be different, magnetic properties will be different, and we find applications of different materials over a very wide field. Almost in all areas we can see some very significant developments by application of nanotechnology.
Thank you, ma'am. You just mentioned materials. So what are the various materials used in nanoscience and nanotechnology?
We can have a very wide list here, a long list of materials, starting with carbon. Carbon is one of the most important things which is being used. So we have here it can be carbon nanotubules, it can be carbon fibers, depending on what we need. We can have fibers, we can have membranes, we can have nanotubes, we can have nanorods. Materials can be carbon, then we have graphene. Again, it's a form of carbon only, but that's very widely used. Then you have silicon nanotubules also, which are being used. Then you can have different types of metals. Metals like gold or silver, and oxides of some metals like titanium oxide, they can be used as nanomaterial. Then you have many other organic substances also, which are naturally also available to us, which could be used. And along with all of this, we have one very special category, which is the quantum dots. Quantum dots this year has received the Nobel Prize also. So this is the use of semiconductors in that quantum size. Quantum also again means smaller size, atomic level of alterations. So quantum dots are being used in many places to incorporate nanotechnology.
Okay, ma'am. We'll discuss quantum dots later also if possible. Now, you discussed a range of materials. Now, those materials must be carrying some element of risk or potential benefits. Could you shed some light on that?
Definitely. I think everything has two sides. So, first of all, emphasizing the potential benefits which we see through this. One thing is, like I mentioned earlier, also advanced properties with the same material, like strength, for instance. So, we can have materials which can be very, very strong, very high tensile strength, we can say, at the same time being very, very light. So, for example, steel. Steel is considered to be a very hard material. But if you, instead of steel, if we are using a carbon nanotube, that has 100 times more tensile strength than steel, right? And it will be lighter. So, when you are able to create something which is stronger and lighter, you can have applications in like something like aerospace, where being light is a very desirable property. Then use of quantum dots, for instance. Optical properties, the photonic application would create, like we are in an age of having a lot of screens and imaging. So that will be very, very better with the use of, these nanotechnology or smaller particles. Precision. Precision is not only in imaging, but in things like targeted delivery. A particle is small, this is a nanoparticle, so it can very precisely act at different locations. So if you want to deliver something or if you want to remove something from a very small area, that will work wonderfully with the nanotechnology or with the nanomaterial because it is small, so it can just go and target that location very easily. The other thing is conduction. Again, for instance, graphene is there. Graphene is now a single cell layer. It's a big lattice structure with just one atom which is there in one layer. So that creates very easy connections, very high conductivity is possible with these materials. So we'll talk further also about how these can be applied in different areas. In terms of potential risks, or what we should be aware about is that the size is small. So that small size in itself can be problematic, like if you're using it in the human body, if you're using it for some kind of medical application, it can penetrate your cells, it can penetrate your tissues, and again, because of small size, removal of that is going to be difficult. In the environment also, we see similar concerns. There can be a possibility of these nanoparticles reaching areas where maybe they were not intended to go. And if they reach areas like maybe think of something like maybe water pollution has happened or they've contaminated a water source where we did not want them to be. So their removal again in a similar manner will be difficult. So they will go into different living organisms, they will go into soil, water, and with that kind of contamination, we can expect toxicity, long-term toxicity, environmental damage, bioaccumulation can happen. And the challenge is this, that as of now, we need to work a little bit more. We need more research. We don't have a proper regulation mechanism also, which can make us aware about what are the potential risks or warn us against that. So we still have a long way to go before we can maybe fully get the benefits and fully be able to tackle the risks.
You just mentioned the application of nanotechnology in different sectors, but the first sector that comes to mind is medicine or healthcare. What are the various applications of nanotechnology in medicine?
So in nanotechnology in medicine, there's a lot of work which is happening because a lot of areas can benefit from this. I'll talk about 3 areas primarily here. The first one is targeted drug delivery. Like I told earlier also, precision is one thing which you can achieve from nanoparticles. So we can use nanomaterials, nanoparticles to deliver medicines. What will happen is that you'll have to give a smaller dose because you know that this will go directly to the site where you want it to go. Normally, how medicines are given is you give a larger dose that at least some of it will reach, because a lot of it is going to go wasted. So when you are sending a smaller dose, that means there is going to be less side effect of that medicine, and it will work more effectively because that whole medicine will be going into that area. This kind of a thing can also be used for delivery of vaccines. And we have a very good example in the form of the mRNA vaccine, like which we recently made for COVID-19. So this COVID-19 mRNA vaccine also used this nanotechnology drug delivery system. The second area is in diagnostics, how we identify diseases. In that also, nanotechnology can have various applications. Two main areas under this. One is images. Images like everything from X-ray, MRI, CT scan, we use these kind of procedures. So in this, if we use nanotechnology, we can use things like quantum dots, which give us better pictures, better screens, better, those outputs will be better. The second thing is, like in MRI, if you have to see a particular area, like you want to see which area has cancerous cells. So you need contrasts between the normal tissue and the affected tissue. Those contrasts come out very well if we use nanomaterials. So what is done is some kind of a dye or something is injected in the body, which will help in different areas reacting, different parts of the body reacting differently. And you have nanomaterials which are biocompatible, which are not going to have any side effects. And the ultimate image which will come, that will come with very good contrasts. Another area in diagnosis is biosensors. Like you have to test the level of something, like different blood tests or tests which we have. In that, what happens is with nanomaterials, like we've spoken, they have more surface area, so you can easily absorb material. So even the slightest variation, suppose there is some abnormal protein being produced in the body, and a normal test might not be able to identify it until it has reached some range, right? Like maybe you need 100 units for the normal blood test to identify it. A nano sensor can maybe detect 3 units also or 4 units also. So for a person, this can be very helpful because at a very early stage, his disease will be diagnosed. So that holds a lot of promise. The last thing is tissue engineering. Whenever we are trying to construct any part of the body, we call it regenerative medicine. So in that, we can have like an artificial blood vessel, which we can create from nanomaterials. They are biocompatible. They also have antimicrobial properties. A lot of those such materials are there. So if you're trying to create some part, they can very well form a temporary structure on which cells can grow and help us engineer that part.
Okay. Now, ma'am, every time a new kind of technology comes to the fore, there is some amount of hope generated as to tackling various challenges. And one such challenge is environment related. So how is nanotechnology going to help that?
So in environment, there are basically two problems. You have waste management, you have pollution, and we can use nanotechnology for environmental remediation. So how we will create a remedy for these problems would be by using nanomaterials in the form of, say, nanofilters, or we can have nanomembranes. They have exceptional absorption capacities, so they can remove the contaminants from, say, air or water. We can also create special procedures in which metal contaminants can also be used. Like nanomaterials also have specialized magnetic properties. So that can be applied like in whichever area. Like recently there were reports that IIT Delhi has created a special nanomaterial which will remove mercury from water. Right? So more of such applications based on whichever in one particular area, whatever problem is major, nanomaterials will find some use definitely.
Thank you so much, ma'am. Now there is another related sector which is sustainable energy solutions. How is nanotechnology going to help us in that particular sector?
This word sustainability is what will take predominance here, because we have ways in which we are producing energy. But around the world, there is energy insecurity also. And we need to think of solutions which work in the long term. So the first thing is whatever we are using right now, we need that to become more efficient. So for that, nanomaterials can help in creating efficient batteries. Storage systems for energy work very well with nanomaterials. They can provide long-term storage without a lot of transmission loss. We can also have we can use special capacitors. We use some supercapacitors to have fast charging, fast energy storage devices. The second area is creating alternatives. If you're using one source efficiently, that's fine. But we still need, like, we have so much discussion on sustainable development where we talk about using of renewable sources of energy, like solar power or wind power or even hydrogen as a fuel. So in all these areas, we have already started using the nanotechnology, like the solar cells which are there. If you use nanomaterials in that, so they have a better potential of absorbing sunlight. So that means they can produce more power, more energy. In fuel cells or hydrogen cell, particularly if I talk about, we have nano catalysts which are being used. So with the use of those nano catalysts, that whole reaction with that in that cell in which hydrogen will produce energy, that works better. So as we are talking about, bringing more alternatives, the challenge which we usually face is how to translate that to actual reality, because in theory it works well. Nanotechnology is the answer to all of these areas where we want to bring advancement and we want to bring solutions which can be sustainable in the long run.
Okay. In two of your answers, you mentioned quantum dots. How is nanotechnology going to revolutionize or has already revolutionized the field of information and technology?
So yes, quantum dots and information and technology, that is where the highest application of quantum dots is seen. So in quantum dots, if I can just say one line, what happens is that it is of the in a dimension where the atom's structure we can in a way interfere with. Like basically electrons are moving around the nucleus in an atom. So you kind of restrict the space for the electron to move. So we say that's confinement. So when electron has less space, but the properties change. The light which it can emit, that will change. The kind of heat it will generate, that will change. In IT, in electronics, in computers, how this will work is one, of course, optics. I've spoken about optics earlier also. Quantum dots are going to be used in LEDs. In all your screens, you will see a better resolution, faster working, faster switching on, switching off function of devices. That will work better with quantum dots. Then the second application also, which we've already spoken about, is rapid charging devices. So nanostructured batteries will be long lasting and they'll charge more quickly. And that's, I think, what we need for the future also. So if you have batteries which work faster, you don't need a bigger battery. So that will allow miniaturization of devices. So we are in that era, if we think of from the first computer to how small our laptops are now, or our cell phone, it's working like a computer. So that all has happened because we could reduce the size of every component. Use of things like graphene increases possibilities of very fast conduction. So signals travel faster, device is much faster, and that's what we look for. Another very big application in this area of electronics is the thermal component. Like a lot of our devices, they'll heat up, right? And not just our devices, not as everyday devices. Think of bigger applications like we are coming into the age of quantum computers, or we have supercomputers. So their control of temperature and, creating colder environments is very, very essential to the working of the whole thing. So these nanomaterials, they don't heat up very fast. So they can maintain that temperature range. So they are ideal if we want to, grow this further, if we want more supercomputers. So supercomputers are taking a lot of space. So we can have smaller supercomputers which don't heat up very well. So we don't spend a lot of money in cooling that whole structure. So that's definitely where we are headed. And we are going to see a lot more application of this. It's already being used in chips and processors, and in almost all devices we will see some nanotechnology inputs.
From the way you explained, you described everything about nanotechnology, it seems that it holds a lot of promise. Now, viewers would like to know from you, where does India exactly stand when it comes to nanotechnology?
So India does recognize the importance of nanotechnology. We have a nano mission also to work on or encourage research in nanotechnology. And we also have a center for nanoscience and engineering, which has been set up dedicated to fund researches in this area. Along with this, we also have a lot of private sector engagement happening. We have a lot of startups which are dedicated to research in nanoscience. We have very good examples of Tata Chemicals. They have done a lot of work in nanotechnology and bringing products related to nanotechnology. Then we have work being done in the area of biotechnology also. So we have a lot of startups related to healthcare, biotechnology and nanotechnology they're incorporating. Like Bharat Biotech is one example. They are trying to create a line of vaccines which will incorporate nanotechnology. We have this pharmaceutical company Sun Pharma, which has recently come up with a nano drug for skin diseases. So of course, we still have a long way to go, because overall in India, a lot of money is not being spent on research in general. But having a dedicated mission for something is one set of an idea that we do recognize it. And in future, we should be doing more in this area.
Now, ma'am, because most of our viewers are preparing for UPSC Civil Services exam, we'd like to know from you the importance of nanotechnology from the point of view of CSE.
From the exam point, of course, that's the most important idea which the aspirant has been, I think, waiting for in our discussion. So the main syllabus specifically mentions applications in nanotechnology. So anything which is a part of the syllabus, obviously, we need to go into the detail of that. No questions asked there. If you look at the previous year questions which UPSC has asked, in the last 10 years, around 4 questions have been asked by UPSC on nanotechnology, and all those questions were about applications. Like they'll ask how carbon nanotube can be used, how nanotechnology can be used, are nanotechnology missions, materials naturally found, things like that they've asked. So anybody who has a basic understanding of the idea, he should be able to write this. There was one mains question also which was on nanotechnology in healthcare. Now this can be asked in other areas also. Like nanotechnology in energy, nanotechnology in electronics, any of these. And even if they don't ask, this can be a very good example. If you're writing about sustainable energy solutions, you can write incorporation of nanotechnology from your end also. This gives a different perspective. If you're writing about electronics, or how, like in India, we have this problem of not growing a lot in the hardware sector. We're doing well in software. So hardware incorporation of nanotechnology can be a very good solution if you have to write a question which talks about that. So aspirants definitely need to prepare it. They need to prepare the application part. Along with that, they need to keep track on whatever is happening. Like we had nano zinc, nano copper. Just a few months ago, they have been allowed. They've been given permission by the government. So this is a good example. This is a recent example. You can write this in agriculture technologies also, which again is a separate topic in your syllabus. So tracking of the applications and understanding what the broader idea is what our aspirants will need.
Thank you so much, ma'am, for your valuable inputs and time. Now, dear viewers, we hope you liked and enjoyed the session. We'll keep coming up with more such videos. Till then, stay safe and wish you all the very best.